What's up, guys? Let's take a look at another CodeWars exercise. This one's called Find Next Higher Number with Same Bits. And by that, they mean the same number of ones rearranged. For example, we can go from 1 to 2 by saying 1 or 01 and swapping those to make 10. Same thing here, we got 127 going to 191 just by taking an 01 and swapping it, because that makes a small change, but it's enough to make it bigger and not too much bigger. It's not the only thing we ever need, but that's going to be my starter, is to find an 01 and swap those two. Let's get it going. I'm going to treat them as strings, but of course you can do bitwise operations as well. Let's say bits equals bin of in, which is binary, but when you do that in Python, they give OB and then the numbers. Otherwise, you might not know it's binary, but in this case, we don't want it, so I'm going to go 2 colon, which is everything past that OB. So if we print the bits, we'll see what we're talking about. And that's 128, that's 1, that's probably 1022, but a little harder to recognize. And our next step is to find that 01 combo that we can swap. But guess what? None of these have it, right? None of these have an 01. We got to create our own. So I'm going to throw on an O at the beginning. We have padding, we have unused slots, and that's the same as in base 10. You can say 9 or you can say 09 and it means the same thing. Maybe on a basketball scoreboard you've got 2 digits and you got to put something in the first one, you put a 0, no problem. So here, if I test this, we're going to see, hey, we have an extra bit to work with, which is what we need. Like if you're going from 128 to a higher number, well, you can't do that because the 1 in any of these will make it smaller. So the 1 needs to be over here. And remember, there's only one 1 in the answer. So, okay, now we need to find the right spot. I'm going to call that index, but we might change it. And we're going to go bits.find, but actually we want to make the least consequential change. Like I don't want to change anything. Let's find one. This one, if we change something over here, that would be like millions higher. But in fact, I want to change this one here, which is just a little bit more to make it the next highest number, but not super far ahead. So I'm going to go rfind, which is find from the right. I always get confused when I do rfind or something like that, because I always think the answer is going to be how far is it from the right, like a negative index, but it's not. It's a normal index. And we're looking for 01, and now we're guaranteed to find it, by the way, because we added that O at the beginning, so there's never any issue of like, what if we don't find it? Just to show you what I mean. Okay, so we're going to swap from the beginning. Same thing here, same thing here. But over here, hey, we're going to swap from spot number 16 way over here, and that's what we had in mind. Okay, so now the idea of the swap thing, let's make that happen. I'm going to make a separate function. I know people complain like, oh, why do you make another function? Well, too bad. I feel like it. So I'm going to say return swap of bits at index, and then we're going to have to return that back into an integer because that's what they want. So we're going to go int of that base 2. Okay, so let's say def swap. We'll just call it s and I, make it nice and simple. So at this point, let's try one that's like guaranteed to work. I always like to put something that works even if it's not real. Like what if we return 1 and then however many zeros that is? Is that going to pass the test for the first one? If so, we're on the right track. Yeah, okay, so we're doing the right kind of thing in the right order. We have no errors, we just have to actually put the logic in here to do the job, right? Okay, and so this is swapping, which means what I mean is like, okay, we go S up to I, and then S of I plus 1, and then s of I, because we swapped those two. But you know what? This isn't generic. Like, this isn't going to swap two things in sequences of many types. This is just doing bits, so whatever. Let's turn that 01 into a 10, right? Plus s, and then I plus 2 to the end, I think. And hey, that passes most of the tests. If I hit attempt, hey, it's passing like, 60, 70% of the tests, and that's pretty good. But there's a problem, which is that some of them need to move, well, let me show you. Some of them need to move, like the stuff on the right needs to get shoved over a little bit. The ones do. So for example, right here, what I did was I found this and swapped it. And that is part of the answer. But they also take this 0 and scoot it over, or like, you know what I mean? You can think of it as scooting the zeros one way or scooting the ones another way. And so what I'd like to do for that is not get into any bitwise, not get into like finding the spot to put it, but instead we can use sorted, because if we sort these, we'll have all the ones and all the zeros, and that does what we need. So I think what I'm going to do is take the 0 out of here and put it over here, and then sort these. So this is like, okay, that 1 is definitely there. But that 0, well, it goes in the pool, it goes in the mix that's going to get sorted. And it might be there, it might be further down. I think we have to join this back up. And let's see how that goes. We have to see, A, did we ruin the ones we already had? No, they were just lucky to already be sorted, because there's usually not much to the right of this swap, so high chance of being fine anyway. And the ones that we did need to change, this does it. So let's see what I mean here. Hey, look at that. It's amazing. I didn't want to get into like, some of their examples are really long, but guess what? It works, and we don't have to take off our extra zeros on the left. Like if it was 001 and we give them 0000001, it's fine. They accept it. So that's nice. We don't have to worry about like padding or stripping or anything. And this, I think, is a nice way to do it because there's no bitwise business. You can think of it as a string, and you can take advantage of what strings do, like slicing, sorting, plus. You could also do, I actually think it might be nicer to do F strings on these, because when I see a plus and I'm talking about numbers, I might accidentally think that we're adding. We're not adding. I did see one solution, by the way, where it used like -1 on the binary, and it was actually -1, not taking away one character bit, But let's go ahead and submit, and then we'll look at the solutions from other people, which, hey, there's one that's super similar to ours, and in fact, it's exactly the same stuff in the same order. Great. This actually, it's not exactly the same. They kept the O there. I put the O in the part that got sorted. I guess it's fine either way, because when you sort a 0, it's going first, right? This one used RE, regular expression, and they're substituting, like, anytime we have a stretch of one, like, if it's like 1 and then some other stuff and then a 1 at the end, and then we shift them all down. I find those to be quite opaque. Whenever I write a regular expression myself, I understand it, but when I look at somebody else's, maybe not so much. This one is doing the bitwise business, which is cool to see. You have plus, basically does what it sounds like. This is shift, so this is like shifting to the right, which is kind of what we achieved with our sorted, and kind of they're doing the same stuff in the same order, it's just a different look, and I'm sure it is faster behind the scenes because they don't have to treat it like a string, they can treat it like bits. And this person did something similar, but not exactly the same. And you'll see that often with bitwise operations, there's more than one way to do the same thing. Just like when we're talking about logic overall, you can say not any versus all not, or you could say while not, or you could say until. There's often more than one way to express the same logic. This one's cool. It uses logarithm base 2 in order to, I'll have to look at that more, but in order to create the magic conditions that lets us shift bits around and get the right answer. I thought this was a fun one. I tried a bunch of stuff and wasn't quite getting it until I realized the sorted business will shove everything to the right just as much as it needs to be. Thanks.